So this is the Junior Cert Higher Level 2018 paper 2 and we're looking at question number 9. The diagram shows the rhombus Q or ST. It is a parallelogram in which all four sides are equal in length. The diagonals cross at the point K and two of the angles are marked X and Y. So again, just check each bit of information corresponds to the diagram as you're reading it or after. Sanjay is trying to prove that the triangles QKT and SKT are congruent. Okay, so a good idea would be to highlight both triangles just so we can visualize what we're talking about. So QKT is this one here. And then SKT is this one here. Okay, so it says fill in the missing statements and reasons in the table below to complete Sanjay's proof. Okay, so you've got, instead of doing the proof out fully, you actually have some steps for the proof here, bits missing, and you have to fill them in. So the first statement is, now remember, if you're trying to prove triangles are congruent, there's a number of ways that you can do that, remember? So you're looking at side, side, side is one way to prove it. Side, angle, side. Angle, side, angle. Or right angle, hypotenuse, and another side. They're the four ways you can prove congruency. So it's going to be one of them that we're trying to prove here. So the first statement says that QT is equal to TS. So QT, set length here, is equal to TS. The reason it says is that Q or ST is a rhombus and all four sides in a rhombus are all the same, so that's okay. Statement 2, QST is an isosceles triangle. So Q to S to T, so the big triangle here that I'm tracing, this is isosceles, and the reason for that is that this side here, QT, is the same as TS. That's the reason. QT, the length of QT is equal to the length of TS. So that makes it isosceles. Statement 3, the size of the angle X is equal to the size of the angle Y. And the reason for that is that, well, that it's an isosceles triangle. The base angles of the same isosceles triangle, if those two sides, TS and QT, are the same, well then the angles, the base angles, X and Y, must be the same. So the reason there is you could say that QTS is isosceles. QTS is isosceles. Statement 4 is blank, but the reason is the diagonals of a parallelogram bisect each other. Now remember, the first thing you've proved here, you know that QT is equal to TS, so that's a side you've proved. Here, down here, you've proved an angle is equal to an angle, side angle, and what side is that? Oh, so now it looks like maybe, because the order of these letters matter, so if you've gone side, angle, and if we can get another side or indeed another angle, then we're good. Well, this is talking about diagonals, so it must be side. We're looking for side here to get SAS. So the diagonals of the parallelogram bisect each other. Well, if that's true, it would mean that XK and KS are at the same length. So the length XK is the same or is equal to the length KS. So that means you've got side, the angle, and the side. So SAS. See that? SAS with the A between the two S's. And over here it was this SAS. So you proved the side angle side for both triangles, which means QKT is congruent to SKT, and the reason is side, angle, side.